Today I'm going to switch gears a bit and talk about guitar wiring. Now, it's something that was a little bit overwhelming for me, at least when I opened up my guitar and was trying to figure out what was going on. And if you don't have a basic understanding of how it all works, then it can be a little bit daunting to actually try to accomplish anything with your wiring. So this will be a multi-part series. So this will be part one. And today I'm going to cover just the basics of voltage, AC versus DC, ohms, and what is ground versus hot, which is, again, a little bit of a hard concept, but once you get it, then you know it forever. I'm Dave with Stringing It Together, and let's dive in. So the very first concept is voltage. It's fairly easy to understand because it's just potential electrical power. So you have your outlet down on your wall there. Here in Canada, that's 120 volts. So that means there's a potential for 120 volts to come through that outlet. Or if it's an oven, it's 240. So that's sort of simple to understand, but it also helps if you understand sort of how electricity works. You can sort of think of it as water, even though it's not totally accurate. So with water, it's flowing, right, from one direction to another. But with water, it's actually moving. Whereas you could almost think of it as a wave in water, because if there's a wave, the water's not actually moving. It's just the force is from here, and then the force is moving through the water. So with electricity, it's not so much that it's actually moving, it's that one particle has, an electron, which is like that thing on the atom that buzzes around and is negatively charged. So when you have a charge, one of those electrons jumps from one particle to another. Now, since this lost an electron, it's now positively charged, and that next particle is now out of balance too. So it's going to jump in a chain from one particle to the next. So it's not actually a flow, it's just one particle charging, affecting the one beside it, and then that's then affecting the one beside it, sort of like dominoes. Maybe that makes sense. You don't need to understand that. You could just think of it as something flowing. And don't worry, I'm not going to ramble on too much about these, but we're going to talk about AC versus DC. So all you really need to know for guitar wiring is that a pickup produces an AC signal. Now AC stands for alternating current, DC stands for direct current. So in a nutshell, direct current flows in one direction. Like a battery, you have a positive and a negative, and then it goes around in a circle in one direction. Alternating current actually reverses polarity, so it'll go from positive to negative, which is actually what you have in your house. So for the light bulb, for example, in your house, it's actually turning off and on very rapidly because it's alternating current. So it's sort of like how you can look at a movie, which is actually just a series of pictures, but since it's moving so fast, your mind makes up for the gap. It doesn't recognize the gap. Same thing with a light bulb in your house. It looks like it's just continuously on because it's alternating so fast in the alternating current that it's actually going off on, off on, off on, off on the entire time that it's on, but your brain doesn't realize it because it's too fast for it to recognize. Maybe that blew your mind, maybe not, but that's AC versus DC. All you really need to know is that AC is what your guitar is in. It's alternating current. It can go multiple directions, multiple polarities, more accurately. So the other concept that you're going to need to learn the gist of is resistance. So all that really means is with the electrons flowing, usually through copper wire in your guitar, there's a certain level of resistance, meaning a certain amount of potential power that you're losing through those wires. Now, that's why when you're wiring a guitar, you need to use a certain thickness. So the thickness that most guitars are wired in is 22 AWG. Don't really need to know what AWG means. It's just a measure of thickness. And all you need to know is that as the number goes higher, the wire gets thinner. So 24 AWG is thinner than 22. 18 is thicker than 22. And typically if you're buying wire, you need to go for a specialty guitar wiring. So resistance is important because when you're turning the volume knob on your guitar using a potentiometer for the changing the potential power, it works with resistance. And resistance is measured in a thing called ohms, OHMs. And if you're looking on a multimeter like this one's an expensive one, but you can buy a cheaper one, you'll see an omega symbol and for ohms and volts, obviously. So you also have on here a red and a black, which represents ground and hot, which you also have on your guitar, which brings me to my last and final but most important point of understanding what ground and hot is. So first I'll give you sort of a theoretical understanding, and then I'll show you with a specific diagram. So basically you have two wires coming out of your pickup, a ground and a hot, okay? So you can think of the ground wire as like your baseline and the hot as your signal, okay? So the sound that comes out of your amp, which if you've ever taken apart or you've ever seen a speaker from the inside, you know that it's a magnet with a little bits of paper that vibrates the air, and that creates the sound, right? So the vibration of the magnet is created by the difference between the ground and the hot. So the pattern of vibration or wave between ground and hot is what vibrates your speaker and creates the sound. Now you may think, well, how does it make it sound so many different sounds? It's not just like louder and quieter and one or two sounds. Well, it's because each note is not just a two-dimensional single wave. Each note that you hear coming out of your amp, or each different tone or frequency, is an overlaid pattern of waves. So it's, if you ever think about a one single note on a guitar, it actually is not just one single sound, it's a combination of sounds that creates the specific tone that you're looking at. It's called the harmonic series. So each note has a bunch of different frequencies playing it simultaneously in a harmonic series. Now, that's going a little bit meta here. Now let's dive into some specific practical examples, and I'll pull up a demonstration for you. So I'm just going to show you a very simple example which will hopefully make this make sense. So we're going to imagine that you've got a pickup and an output jack. So you've got a guitar, it's got no volume potential, no tone pots, and no switches. Just two pickups, a set of pickups, and an output jack. So on your output jack, you see two connection points. Now one of these, the hot, is connected to this part here, which is what lines up with the tip of your jack. And then the sleeve of your jack lines up to this actual metal here. So the ground goes to the sleeve of your jack, and the hot goes to the tip of your jack. So the two parts of your jack are actually not connected. If they were connected, then you would have no sound, because it would just be, there would be no difference between the ground and the hot. We'll get there. So I'm going to use red for hot, and I'm going to attach that here. And then I'm going to use blue for ground. So I'm going to attach that here. So this hot is actually going through here and up to the tip here, and this ground is actually going to the sleeve. So when you play your string on the guitar, which is made of nickel, which is magnetic, it's then creating a sort of interference pattern with this pickup. Each of these is a magnet, and the actual pickup itself is a very thin piece of wire that's wound around a magnet. And now I don't understand fully how these things work, but basically, since it's so tightly wound, you're able to create a unique interference pattern when you play the string in a vibration that then sends that signal through your hot wire. Now, in this case, you would not be able to turn off your guitar because all you have is a ground and a hot, and there's nothing that is going to end that interference pattern going out to your amp and vibrating it out. Now that's where the volume comes in, and what the volume does is it doesn't stop the signal as if you cut this, like with a basic circuit, a switch, you're just basically separating the wires and stopping the signal. That's not how your guitar works. You actually have a volume that instead of stopping it, it just sends the hot signal to the ground and a certain percentage of it as you turn your pot. So I don't want to overwhelm you with too much information at one time, but what I want you to do is just sort of mull that over and think about how ground and hot works and how it relates to your guitar and producing a sound. If you want to really nerd out on it, then I'll put a link down below to a link that'll get more into depth of voltage and ohms and how it's calculated and how electricity actually works with the polarity and everything. But for now, for a practical understanding, that should be a foundation. We've covered voltage, which is potential power, ohms, which is resistance, AC versus DC, which is how the electricity flows, and ground versus hot, which is the most important for understanding guitar wiring. So stay tuned next week. We'll get into volume pots, and if you found this helpful, give it a thumbs up. Don't forget to hit subscribe, and that'll notify you and turn on your notifications, so that'll notify you for next week when part 2 comes out. Stay tuned. I'll see you then.